right, guys, welcome back. Right now, we're going to talk about point slope. We're going to talk about point slope. Pretty easy subject. I actually really like point slope. There are a lot of people who do not like point slope and go straight into slope intercept. The main question I always get from both student and teacher is, why? Why would you make it more complicated with point slope? I actually think point slope is a lot easier in certain situations. So, to recap, point slope looks like this. Y minus y1 equals m times x. That is not supposed to be a triangle, guys. X minus x1. So what does all this mean? Okay, so the y and the x are the same thing. They are our output and our input. The y1 and the x1 are a known y and a known x. That means we've been given a point that is not our initial value that we actually know. So we've been given a point that is not 0y. It is not our initial value. This equation allows us to plug in really easily to find our initial value, which is really cool because we already know the x for the initial value. It's 0. So let's take a look. Y minus 3 equals 1/5 x minus 2. What this tells us is that we have a line that passes through 2, 3 with a slope of 1/5. Oops, sorry about that. With a slope of 1/5. We have a line that passes through 2, 3 with a slope of 1/5. So we can actually plot that now. So 2, 3, 1, 2, 1, 2, 3, and 1/5. So 1, 1, 2, 3, 4, 5. And if we wanted to, if all it was asking was for us to draw and graph the line, we could actually stop right here. There's the line, guys. It's done. We got it. Well, let me make that a little bit better, but yeah, the line is pretty easy to figure out, right? Just like slope-intercept, we plot our first point and then use the slope to find the second one. Easy enough. What's unique about this is if we want to find the intercepts, it's really easy to do. So let's say we want to find the y-intercept. We want to find this. So we input y minus 3 equals 1/5. And we know that the y-intercept has an x of 0. So we put 0 here minus 2. So 0 minus 2 is negative 2. And then times 1/5 is negative 2/5. Add 3 to both sides. And yeah, guys, this is going to get messy. So, best bet here, we convert to negative 2/5 plus 15/5. And we get y equals negative . Nope, I'm wrong. It's not negative. That's my bad. 13/5. It's not negative, it's just 13/5. Negative 2 plus 15 is 13/5. So again, guys, sometimes I make these mistakes. And we can kind of see that right here. Notice it crosses the y-axis right above 2. Below 3, but right above 2. Right about that halfway mark. So point slope is actually really useful. Let's say we wanted to find the x-intercept, which is somewhere over here instead. Well, again, we know that in an x-intercept, y is 0. So 0 minus 3, 1/5, x minus 2, get negative 3 equals 1/5 x minus 2 over 5. We add the 2 over 5 to both sides. We actually get negative 13 over 5. Again, kind of reversing it this time. Equals 1 over 5x. Multiply by 5, because this is basically being divided by 5. You'd cancel out that 5, and what you would get is x equals negative 13. So our x-intercept is going to be at negative 13. Y of 0, x of negative 13. So again, I kind of like point slope. It's super easy to use. I encourage you guys to play around with it, as well as playing around with slope-intercept and conversions of that. Don't get stuck in one methodology. All right? Don't get stuck in like one view of like, I have to do it this way. There are a lot of different ways you should try out, because sometimes one way is not going to work for you all the time. You may find down the road that the other way, just knowing about it, works a lot better. With that said, guys, we're right about our 7-minute mark. Again, this is going to act as kind of a test review guide. This is going to act as our exam review guide. I think this is a really cool idea and a really cool way to do it, and I'm hoping I can continue it in the future. I will see you all later, and I hope you have a wonderful day.